In front of you now is a general list of what we're going to try to cover quickly today. Many of our enhancements are what we call general enhancements, so pretty much any GibbsCAM user will be able to benefit from those, regardless if you do more turning or milling or 5-axis or what have you. So these are things that can help everyone, and we will kind of take them in these categories, and some things I will just speak about, some things I will show you, a few things we have videos on. We have a lot to cover, so I'm not going to spend too much time on any one item, and we'll try to move along and allow time for questions at the end. So we'll start with our general enhancements. The first one is NLO license borrowing. So if you have a network license at your facility and you share licenses, you will now be able to actually check out, or what we call a roaming license. You actually check it out, for instance, on a laptop, and then roam with it. So you could take it home, for instance, over the weekend, or if you're away from a week, and it will still use up that seat, those items that you've selected, but it will keep it local on your computer. And then when you return, you can check it back in, or there's the license can be returned automatically in 30 days, or there's a way also for administrators to override that. So very useful if you want to work remotely. Okay, so as you've probably heard, we're starting down the road of AI with GibbsCAM, and one of our first I'll say features to work on this is the GibbsCAM Copilot. GibbsCAM Copilot is accessible through the help menu. And basically it's just a ChatGPT utility, so you can input a question or a topic. So you can see I entered swarf milling, and it told me what I have to do to perform swarf milling in GibbsCAM, and even some additional tips down at the lower portion. If you get some information that you don't feel is right or not accurate, then you can give it the thumbs down feedback, and then our team will review it. And this is so we can keep the information within this chat box. We can keep it current and correct and accurate. Just a quick one here that you can't really touch and feel this one right out of the box. You'll need a post upgrade for this, but if you have machines that use maybe smoothing or high speed functions that need to change, either have a direct tolerance number, or they use like maybe an R value or something like that, any given tolerance in a GibbsCAM operation can now be accessed through the post, and then that proper coding could be output for those types of things. So if that's something of interest to you, then I would contact whoever supplies your GibbsCAM post processors, and they can make that work for you. Our next one is a solid attributes. So we've had solid attributes for a long time, and that's not an issue. You see these particular part has some features, and they have attributes, they have colors, they have a clearance in the top face, etc., what CS they belong to. So these attributes we want to keep with this solid. So in past versions, the problem was if you ever copy and paste this between versions or within a session, the copy would not retain these attributes. So we've changed that now, and these attributes will be maintained with a paste. All right. Containment and overlap mouse drag. This is a long time coming. I'm happy about this new functionality. So we now have the ability to have a dual functions for our window selection. So currently it doesn't matter if you do a left to right or right to left window, you'll get the same result. So currently we work in the overlap mode only. So now in 2025, by default, if you shift drag a window left to right, will have this overlap scenario. Some systems would call this an intersect or a crossing or a clipping. So basically, if you touch any entity with that window, it'll be selected. And that's the behavior that we're all used to in GibbsCAM. But now you can also change to drag a window from right to left. And now it will be exclusively items that are fully contained in that window. So just intersecting it or overlapping isn't good enough. The entity has to be fully contained. And this is very helpful when you're doing other selections, like maybe even faces of holes on the solid or that kind of thing. You want to do a select, but you don't want to select all those other faces around it. You can usually get in the correct view and then do a quick right to left window, and only those items that are fully in the window will be selected, and all the other faces on that solid will be ignored. So, and another nice feature here is that if you prefer that the left to right, right to left behavior is the opposite, so you want to run it more like, say, something you're used to like SolidWorks or Autodesk, then in the preferences, you can change your default from right to left to right. So you'll have, either way, you'll be able to do that. We also have a deselect by mouse drag. So the same mouse drag, left to right or right to left, applies here, but now either in the edit selection menu or using Control Shift, you'll be able to deselect as well as select. Okay, and then finally in this group is the selection filter. And so this allows you to filter out certain entities with a current selection, and I'll show that to you here. All right, so let's take a quick look at these functions. So we're all used to, if I just do a shift drag, we see that anything that crossed that window got selected. But if I do the same thing from right to left now, you notice that only the items that were fully in that window were selected. And again, you can go to the File Preferences. And if you want it to be the opposite way, you can just change it here. Very simple. So now we'll take one, we'll select this, and now I could use it here, deselect, or what I'll just do is do it here. I'll hold Control plus Shift. And now you see it was deselected. Okay, so working with GibbsCAM, we do selections obviously all day long. So this is going to benefit everyone. Nice new feature here. Okay, this is another nice one, Toolpath Redraw. So we have some new options in the preferences where we can either control tab behavior on your operation list. So this number 7 here. This is what we would consider the tab, and also the tile, which would be the complete tile. And this will automatically redraw the toolpath. And this one will be easier to show you. So we're all used to, by default, if I click on a tile, I want to see that toolpath, I'm used to having to come over here and maybe move the mouse a little or whatever to get that to redraw. But now we don't need to do that if we set these preferences. So we'll start with, let's say, a tile. So if I want to do nothing with a tab and select tile and redraw with a tile, then any tile I select, you see it immediately redraws, and it saves me that step from that we're used to having to go and zoom or rotate or manipulate the model in some way such that the toolpath will redraw. And I could also limit it to just tabs if I want just the tabs to do the redraw for me. So here I'm just selecting the actual tabs, not the tiles, and you can see that it's redrawing. Okay, so in a way it's small, but it's a big new function because it's going to save steps in the long run, and a very useful function. Okay, still on general enhancements, we have OpTile list modes. So these are new modes for the operation tile list. So this has to do with if you're using MTM type of machines or Swiss, so some machine with more than one flow. So now we have a mode here. We can show each flow instead of just having that one column. So you see this example has 3 flows, and you notice on the empty tiles, there's a watermark showing you which flow it is. So a lot of feedback for you. And then the other mode is to align the sinks for you. And it makes it easier to, see your sinks all lined up. Now, it's important to note that this does not replace Operation Manager, your Sink Manager. So your Sink Manager, you still need to do all your sinks and all, but this is just, while Sink Manager is closed, this is just an easier way to look at multiple flows. Some other enhancements, simulation. This is more for kind of like the first time you use a sim or even install a GibbsCAM, but for safety reasons, by default, we're forcing the collision checking and a program error to be on by default, as well as the log to display. That way there will be some notification of collisions by default. We've also got a new stop type in simulation. So now you can stop before every operation. So just like if you were running a machine and used optional stop and had that on, say, at every op, then this would do the same thing in simulation. Another real nice feature here is a scrolling bar in simulation when you have the Sink Manager active. So this will scroll through in the same time as your simulation, so you can see exactly what operations are being performed while you're watching the simulation progress. Another improvement in simulation is the rotary hints. So on the right there, you see the rotary arrow hint for a part spindle. And on the left, you'll see it for a tool spindle. And so this is turned on in the context menu for Machine Sim. Just more feedback about what's going on as you're watching simulation. And analyze cut part tolerance. In previous versions, I believe this was only for remaining material change, but now this tolerance is also available for other analyze features. All right, so I'm going to show some of these features. Okay, so this is a 2-flow machine. So if I come on over here above my operation list, you'll notice we have a couple new little icons here. So we have show each flow. So now each flow is in its own column instead of just one very, very long column. Or we can show these as they sync. So we'll line up the sync markers. Okay, again, not a replacement for your Sink Manager, but it's just an easier way as you're programming to look at what's going on with your multiple flows. If I do have the Sync Control Manager active and I go into Machine Sim, you'll notice here that there's a red bar now. So as I start my simulation, this bar will follow the progress. Let me know exactly what's going on. And also, we have the show rotary hints. So you can see here's one. And this is for milling. Let me rewind this so we can look at it again. And it will show on any spindle that's active. So here, this turning spindle and this part spindle here. And here you see it for the tool spindle. Okay, another enhancement, intermediate tooling fixtures. So there's kind of multiple things going on here, but one general set of improvements is if you're using clearance volumes, your MDD has to be set up to use that. So if you're doing 5-axis work, say with some odd shaped parts, and you want to have the system automatically give you the best clearance volume instead of just one set Z clearance, then you would use clearance volumes, and now the transition moves, between ops and all, and the clearance volumes do a better job at avoiding collisions with all type of fixturing, even IT fixtures. And the second part of this is most of the solid machining processes now. So you see here I have a roughing process, I have an advanced 3D process. They have a checkbox here that we can use for avoid IT fixtures. So instead of just a workspace fixture, if you have an IT fixture, a chuck or a vise, it'll avoid it the same way it would in a workspace fixture. So it would use your advanced settings if you need, or the default settings for what's the clearance is, to the distance to avoid those. And let's take a quick look at that. So this is an intermediate tooling fixture. So for those of you not familiar with that, I'll go to my DCD, intermediate tooling, and you'll see under fixture, I have a fixture defined here. So if we take a look at this toolpath, it's very obvious that that's not going to work for us. It's going to slam into that fixture. So to fix that, I have avoid IT fixtures available. I'll turn that on and redo. And now you can see that's avoided. And the same for this advanced 3D. You'll see it here. So any process that supports the direct selection of a solid should support this, and it just gives you a little more power in reason to use IT fixtures for things like chucks and vices and that kind of thing, where you can basically build a fixture library. All right, this is a pretty large enhancement, actually. It's quite powerful. So this is facet body modeling. So we've been limited in the past of we can read a facet body model in. We can generate one with our simulation, but we really couldn't do a whole lot with it. It was cumbersome to even move it around. So that's all changed. So we have a new toolbar, a new tool palette that you can see there with 5 new commands in it. We can tessellate the facet body, so you can create a facet body from something. And there's also, as you will see in a minute, there's some what we call feature recognition functions in it that just make the facet body easier to work with. We can simplify the facet body or refacet it. We don't like the facet pattern or what have you, or the number of facets, and we can control all that. We can heal facet bodies, so it'll attempt to basically make it watertight. And we can smooth the facet bodies. It's got too many facets on a cylinder, for instance, and then smooth that out. So this is just a part of the many improvements because they spread throughout many of the modeling functions we've had for many years. So a lot of the solid functions such as Boolean, slice, separate, offset, and your history, these all support facet bodies now, and I'll show you in a minute here that we can use the two together and let them interact and use some commands we've been used to using over the years, and those will also apply to facet bodies. And just a note here that because people are always asking and trying to bring this out up front, is that no matter what we do to these facet bodies, and even if we work with them in conjunction with other solids, when we're all done and we have the result we want, we still have a facet body. So this is still a body that's just a bunch of triangles, and it is what it is, and that's all we have at this point. So we're not going to turn it into a solid model. You're not going to get good parametric geometry out of it for running toolpaths. So you can still run toolpaths on it, but you won't automatically get arcs and that kind of thing. All right, so let's take a look at this. So here I have actual several bodies, and we can see, you see we have this option to look at facets. So if I turn my face selection on, but I have facet selected, you'll see I'll see the individual facets. Or I can look at these as surfaces. And right now, if I use face selection, you'll see this one, it's just selecting the entire thing, but that's because we have not done any processing for it. So we'll show you how we can get around that. Okay, so let's start by working on this guy down here. So what I'm going to do is take these out of the body bag. That's 3 solid cylinders. Let me turn face selection off. And we'll use our subtraction command. You notice here that it's subtracted. So we can now operate on a facet body with our solid modeling commands. I'm now going to come here and tessellate with our feature recognition. And now you can see this allows us to select these, for instance, as individual faces, even though these are still faceted. So even though they're still faceted in the background, this utility helps us use this, operate with this more like a normal solid. It's just easier for us to work with. For instance, let's say I want to offset that face. I'll offset it 1/2 millimeter. It offset that 1/2 millimeter. All in one shot, selecting one face. Yes, in the background, there's multiple triangle faces there, but for our working with it, we can use it as one face, makes it all easier for us. What we can also do is the opposite of putting 3 holes in. Maybe I want those to go away, so we can unstitch those. And I'll come up here and kind of do the same feature recognition with this. And I'll select these faces and unstitch it. and I could make that go away. For this one, I'm going to do as surfaces. So now you can see we have individual faces. What I can do with this face is just, you see how coarse representation it is. I can smooth it. And this gives me a lot better looking. Another thing that was asked last session is once I've gone through and kind of created a, if you will, a feature out of this thing, then it will support visible edges. So I can, extract the edges, or I can still use the profiler if I want, and I can get edges. And what that also allows us to do, like here, we could do, for instance, some dimensioning. So we could dimension the facet body. So again, we can do so much more now with facet bodies. And one more thing I'd like to show you that was one of the main requests for having this functionality is, let me bring this in. Here's a case where we have multiple parts on a tombstone. So we ran one part, ran simulation, and saved the STL, and we get the stock model. Now we copy that stock model to this side, turn it upside down, and this is the stock for the second op. So far, so good. Now we run the first face and the second face through sim, and now we want to save the result of the third one, this one, because we want to make that for the stock on the third one. The problem is when we create that, this is one multi-lump body, and we can't move these individually. So now it's a very simple solution. Just use your separate command in solid modeling, and now this is two separate solids, and you're good to go. So very simple solution to a thing that's been a little bit of a problem over the years. Okay, so that is facet body modeling. Another enhancement is the tool data. We just added a couple more fields. We're calling it cut width and depth. They're actually the radial depth and the axial depth of the tool. So that can now be stored in with the tool data. And of course, we'll look at OptiThreading in a few moments, but that data is also stored with threading inserts. All right, now we're going to look at some turning specific enhancements. So we have a new roughing strategy for grooves. We call this rib cut or rib cut plunge. So the idea here is to have repeated plunges at full engagement, and then the remaining ribs are purposely made narrower the insert width, and that way none of the edges of the insert are actually being engaged. So you have full engagement and then limited engagement, and with that strategy, both of these passes will avoid any tool deflection. And this is designed mainly for deeper grooves. It works well for what we would call deep grooves. So I want to show a quick video on this. Okay, so here you see full engagement and then much less than full engagement. So you can find it here on the roughing. You notice you can control the rib cut feed percent and the speed percent. You can do PEX if you need to, but depends on the material. And it's a very efficient way of removing a large amount of material. Okay, so that was rib cut plunge. Another nice new turning feature that we have is the Sandvik Coromant strategy OptiThreading. The biggest plus of this is you can control your chip breaking. So we've all seen threading where the chips are a mile long and they can get wrapped up around your part and you'll have to stop the machine and clean everything up. You can make all that go away with OptiThreading. I was able to test some of this, and depending on your settings, you very much can control how long your chip string is, depending on your settings. So you have kind of full control over that. It does require tooling data from Cora Plus tool library, so you'll need to be signed up for that library. You give it all the information that Sandvik requires, and then you pass it on to GibbsCAM, and all you care about in GibbsCAM is that use OptiThreading is shown as on for that tool. And once that is the case, then you can now choose OptiThreading. So again, you need the Cora Plus tool library. Bring the tool in, and you'll notice this tool, if we check the cutting data, use OptiThreading is on. So now I'm able to use OptiThreading in the process. And you can change things like your oscillation frequency and the extra height of it and the clearance. So you see it's an oscillating type of toolpath. And although it may look like it beats up an insert, it actually is just the opposite. It actually gives you longer insert wear. And depending on where you set that oscillation frequency and even the extra lift value is how you can control how long your chip strings end up being. So here's a conventional, and here's the familiar very, very long strings of chips. And this is in comparison to the exact same thread, the exact same number of passes, but we're doing with the oscillation of OptiThreading. Okay, our next item in turning is not really new for 2025. This one kind of snuck up on us. We could really always do it because of just the way our UKM architecture is in our product. We just needed a way to do it, which was right now by intermediate tooling. And it's kind of new on machining too. Only certain machines do it. So we've been working over that on the last year and testing it on machines. So we decided we would at least let everyone know that we can do this, even though we could do this prior to the 2025. So you can basically use it with any turning process as long as the machine will support it and you have the correct tooling. So the insert is positioned in the YZ plane. So it's basically cutting in front of the part. And the idea with the part turning, it pushes right up into the tool spindle and all the forces go directly up. And then you're not going to be flexing that tool at all. And with if you have a programmable axis on that tool, now you can at minimum position optimally for the work you're doing. And if you go further and you have one that can do simultaneous, then you can actually do what we call a sweeping motion. Okay, so you see the tool here is cutting in the front of the machine, which you're not used to seeing. And these are all normal processes. There was volute turn, there was roughing, there was prime roughing. And this continuous sweeping is we treat more like a B-axis turning if you've ever done that before, but instead of a B-axis, we're using that local tool axis. And right now, the only thing that's required is you have to set up a tool holder as intermediate tooling in the right coordinate system. And that's how you do it the same way in Gibbs. And then it just puts everything in the right coordinate system for you. So there's very little difference than just normal turning from that aspect. And here you can see the sweeping. So we've actually determined and actually drawn the vectors of how we want that tool tilted as it goes across that part. So again, something we've been able to do and can do. Not all machines can do it, but we have tested on quite a few different types, and I think more machines are getting ready to support that functionality. Another quick one here for you folks using Swiss machines. We now can define a headstock origin. So basically you're sliding headstock now, especially for purposes of machine sim, will be located in the correct position when you start the part. And it's also easier to input like the starting part length and all in the DCD. Okay, some milling enhancements. So those of you using the Tombstone management system, there's been some issues with TMS working correctly with our new way of doing work fixture offsets. So that has all been cleaned up and should not give any problems moving forward. Okay, mill feature top surface Z equals auto. So basically, because a feature can be anywhere and we're going by the top of this feature, whether it be walls or even a floor, then it makes sense that the start position of that feature, your starting Z, is basically variable. So this is why we call it auto plus. This is a plus or minus clearance from where the feature is, when an absolute value wouldn't really work for you. We also have a feature here that we can overlap finish walls when you're doing material only. So your rest machining maybe didn't clean up enough. You just need a little more extension. So here we can put an extension on the toolpath. And again, I'll show these to you in just a minute. And then Operation Manager now supports additional fields for volume mill and 5-axis. I'm not sure of all the fields. I do know there's some, like, I don't even see it there. I must look at the other one. I know like the step over amounts and all that weren't included before are now supported. All right, so here we see we have a feature we're cutting, and the first pass is starting below the part here, which may be fine, but maybe depending on this feature and all, we want this to be a little larger. So we'll just put 0.1. So this isn't an absolute, it's just 0.1 from the start of the feature. And we're basically moving that start point and adjusting it. Also here we have a material only. And so it's just grabbing leftover material in this corner, and this may be technically accurate, but we could be just getting the tiniest of a tool mark right here where it's blending with already machined, and we have a reason that we just need to pull that out, or maybe we want to bring it all the way to this before this curves portion. So now in open sides, we can adjust that simply with that one value. And now you can see that's been extended. Okay, and finally, any one of these. So you have volume mill here. Yeah, so like step over, I don't think we could get to before, and there's some other fields that both in volume mill and in 5-axis were not available, and now they are. Okay, machining order. So if you're selecting, like I have here, I'm selecting the floors of 6 pockets. And what we're used to is, regardless of what order I selected those in, GibbsCAM was still going to pick its own order. If it wasn't what we wanted, we'd have to drag tiles around, which is a little bit cumbersome. So now there's an option to either do automatic, which is the legacy way, or from selection. So it will now take the selection you pick them in, and it will run the toolpath in that order. So that's a nice change. Okay, 5-axis. I'm not going to show anything, but I do want to run just through some items here. So in multi-axis, we have minimized links and roughing. So it attempts to minimize how many link moves there are. This is an interesting one, user-defined clearance surface and roughing. So we're used to having clearance planes, and we have clearance cylinders, and we have clearance spheres. But here we can actually pick a surface, and that surface becomes the clearance that it's going to retract to. So depending on the shape of the surface and where along the toolpath the toolpath is when it retracts, that's where it's going to retract to. So that'll give quite a bit of power for some very specific retracts. Rotary machining, there's now some leads for roughing. There's also a new option to machine by groups. So that's in addition to like level and area. So you can also machine by groups. There's user-defined radial slices. In swarf machining, this one is not an option you're going to see in the interface, something you can check or turn on, but the whole internal calculation of the way the tilting works, all the algorithms have been updated. There's a new calculation, so we are supposed to now get better, improved tilting results in swarf machining. And also gouge checking, we can gouge check the individual tool parts, the holder, the shaft, the flute, and all, just like we can in other areas of 5-axis. For deburring, they've worked on, again, improving the order of cuts, because we know deburring is really more of a pick the part and go deburr it kind of thing and let it automatically go find what it can. So it decides on the order. So we want that to be the most efficient it can be. So that's been improved. Corner arc support for chamfer tools. In geodesic, they've improved the corner smoothing, and they've also improved the medial axis cuts. In linking, even though we have a very long list of lead in and lead out types, we've added yet another one, and this one is called fade. And then finally, in multi-blade, we have a separate edge rolling setting for leading and trailing edges. So before you set an edge roll, but it was the same for the leading and trailing edges, so now they're separate, as well as feed rates for leading and trailing the edge rolling moves. You can have separate feed rates for those. All right, and finally, again, as 2025 is our first version where we're starting down the path of AI. And another option, so this is an option, this is a third-party option plugin. I just wanted to make you familiar about it. We're not going to get into it. And then if you have interest in it, I would recommend contacting your reseller and asking them about it. But UpToParts autoCAM is an AI-driven automation that helps to automatically program, especially prismatic parts like you see here. So it's going to look at, materials, what your tooling are, what your processes are normally, how you program, what your machines are, materials. It can get PMI data off the model if it comes with the model. And then we'll pass that information on to GibbsCAM for it to create the toolpath. So GibbsCAM is still creating the toolpath, and you can edit and do everything you're used to doing in GibbsCAM at that point on, but it's trying to upfront quickly speed up the process by identifying what needs to be machined, picking tools, giving suggestion for processes, and then sending that all to GibbsCAM, and it will calculate the toolpaths. But this is just a little quick video of kind of what that looks like. And this will be coming out very soon. So you can see the features it finds, and it finds it on the different faces. And that whole CAM project is exported. And then in Gibbs, we'll import that project. And now you can see you've got their tool list, you've got all your operations, and now you can work with it like you normally would in GibbsCAM, but it's just done much of the work for you at this point. So that's just a quick introduction to Up to Parts AutoCAM. Like I said, if that looks appealing to you, then I would recommend you contact your reseller and get more information about it.
My thanks to Bruce to putting that all together. Thanks, Bruce, did a great job there. And of course, we're always around. If you come up with something, think about something later on, guys, just talk to your resellers. They can email us and ask us questions. But appreciate you all attending today. Enjoy the rest of your day. Thanks, everybody.
Thank you.